Hi there, and welcome to Tony's Science Tidbits. We're going to look at part 3 of our lesson on matter and the particle theory today. This third part focuses on the particle theory itself. Remember that this is a theory, and if you don't recall what a scientific theory is, please stop the video now and search it up. I will expect you to know in class. Okay, let's continue on. Scientists developed this particle theory to assist them in describing the structure and behavior of matter. There are 5 main points to know about particle theory. We'll review these one by one in this video. The first point to note is that all matter is made up of tiny particles. These particles are so small we cannot see them with our own eyes and need special instruments to identify them and show their existence. Woohoo! This is true for all states of matter. No matter how solid something feels and looks to us, it is composed of much smaller individual pieces. Secondly, all particles have spaces between them. As shown in this snapshot from the clip on the prior slide, no matter how closely packed particles become, there is still space that exists in between them. The third point is that particles of any specific pure substance are all the same, and that particles of different pure substances differ from each other. Take gold and silver just as one example. All particles of gold are believed to be the same, and all particles of silver are believed to be the same. However, the particles of gold are unique and thus completely different from those of silver. Fourthly, particles are always moving. Again, this is probably tough to imagine in solids, as they seem very rigid to us. It's hard to picture the particles it's made of moving, but it's happening at a microscopic level. Particles require energy to move just like you and I do. And if you look at this particle simulation, we can see that the microscopic view of the water particles are animated on the screen. On the bottom, we can control the temperature of the water. As we increase this temperature, the particles in the water start to move around more and move further apart as they gain this energy from the heat. So remember, particles require energy to move just like you and I do. As we take away the energy or cool it down, the particles slow their movement. As we increase the energy or heat it up, the particles move around much more actively and move further apart from each other. Lastly, all particles have an attractive force between them. The closer they are together, the stronger the pull of attraction, like microscopic gravity pulling them together. As we watch this particle simulator, we see particles start far apart, but as they pass close to each other, they are eventually drawn together, and the greater the size of the group of particles, the more attractive pull there is.